All right, welcome to lesson 1.3 for pre-calculus, and this is our first lesson of the year, so here we go. All right, the warm-up here says find the x-intercepts, and then it gives you a little hint here. It says x comma 0. Basically what that means, to find an x-intercept, you substitute 0 for y. And to find a y-intercept, you substitute 0 for x. 0 for x. Alright, so here we go. On the first one, the y-intercept's usually easier, so I'm going to go ahead and do that one first. So y-intercept here, this is going to be f of 0, so we're substituting 0 for x, and that's going to equal 0 squared minus 4 times 0, which obviously is equal to 0, which means I have a y-intercept at 0 comma 0. Alright, x-intercept. You plug in 0 for y, so x-intercept. So we're going to plug in 0 for y this time. That's 0 for f of x. And we get x squared minus 4x. Now, this is a tricky problem because a lot of people forget to always look for a common factor first. So when I go to solve this, I'm going to factor out an x, and that's going to leave me with x minus 4. And then once I have my two factors, I'll set each one of them equal to 0. So I'm going to end up with two solutions here. I'm going to get x equal to 0, x minus 4 equal to 0, and I'm going to end up with two answers. One of them is 0, 0, which should make sense because my y-intercept was at 0, 0, so I should think of that also as an x-intercept. My second answer is 4 comma 0, so this thing has two x-intercepts. And hopefully that makes sense because parabolas can have two x-intercepts. My second equation, y-intercept again here. So we're going to go with the easier one first, y-intercept. Alright, so we're going to plug in h of 0, and that's going to equal negative absolute value of 0 plus 4 plus 3. And so 0 plus 4 is 4. The absolute value of 4 is also 4. But then we have this negative out here, so we actually end up with negative 4 plus 3, and that leaves me with negative 1, and a y-intercept at 0, negative 1. X-intercept, I'm going to start up at the top here. We might need a little extra room. X-intercept here, we're going to do 0 on the left equals negative absolute value of x plus 4, and then plus 3. So I need to solve for x. So when I go to do this, we're going to subtract 3 on both sides. We're going to end up with negative 3 equals negative absolute value of x plus 4. We need to get rid of the negative over here, and technically that's a negative 1, so we're going to divide both sides by negative 1. And we're going to end up with positive 3 equals the absolute value of x plus 4. So when you solve absolute value, there can be two solutions just like a parabola. So it's kind of like when we factor and solve a parabola, but in this case, what we're going to end up with here is we're going to end up with x plus 4 equals positive 3, and x plus 4 equals negative 3. Now, there's other ways that you might have seen that when you first did absolute value, but basically you need to end up with a negative side. Okay, so my negative side is with the 3. So a lot of people will do the negative side with the x plus 4 as well. So if we subtract 4 over here, we get x equals negative 1. If we subtract 4 over here, we get x equals negative 7. So again, we've got two solutions. We've got negative 1 comma 0, and we have negative 7 comma 0. I'm going to figure out why my screen's... Okay, so we're going to start out today talking about relations and functions. And when you hear these terms, some of them are important, some of them you just kind of need to know, hey, that's what they're talking about. So a relation is basically any set of ordered pairs. Okay? Any set of ordered pairs. So that could be a single coordinate like negative 1, 0. That could be a whole bunch of coordinates, or it could actually be a graph like a parabola. A parabola is made up of a bunch of points. A straight line is made up of a bunch of points. A function is a correspondence or a rule that assigns to every element in the domain. So for every x in the domain, there's exactly one element in the range. Okay? What that means is that each member of the domain pairs with only one member of the range, or for each x there is one y. So when you hear things in math sometimes you get more mathematical terms like the top definition here. But basically what it means is for each x there can only be one y. So when we start to look at whether something is a function or not, we're going to look at, here's a set of ordered pairs. Okay, tell whether it's a function below and explain. All right, so I start looking at these. I don't care about the y values. All right, the first thing I'm going to do is I'm going to look at the x values. So I'm going to look at -3, and I'm going to find out if there's any other coordinates with a -3, and there is. So this coordinate here and this coordinate here. So those two coordinates there, so -3 is paired with 0 and -3 is paired with -2. That you can't have. All right, I'm going to go along and I'm going to look for any others that repeat. It looks like we have another one right here. 4 goes with 2 and 4 goes with -5. Now it doesn't matter if there's only one pair where you have repeating x's, then it's not a function. So the answer here would be no. All right, and x equals -3 and x equals 4 are both paired with and you can just say more than one x, more than one y, then one y value. All right, and so if you think about that, if you look at it graphically, okay, like we've got going on down in the bottom here, now all of these coordinates you can see the x's and the y's, but if you look at letter B, do I see any x's that are the same with different y values? And I'm not seeing that down here. Okay, so if I start looking at these guys here, this is definitely a function. This is yes. All right, and all x's are paired with one y. Now if I go back and look at example A for a minute, I'm gonna plot two of the points, -3, 0 and -3, -2. So -3, 0 would be -3, 1, 2, -3, 0 would have been here, and -3, -2 would have been here. And what you notice is those points are sitting on top of each other vertically. Okay, so anytime I have points that are sitting on top of each other vertically, then I have a single x paired with more than one y. If they're sitting horizontally, okay, like you look at these 2 points here, -2, 1 and 3, 1, those are different x's with different y's. Those are lined up horizontally. That's okay. So when I look at letter C and I'm asking myself, do I see any x's paired with more than one y? All I've got to do is look vertically. Now it doesn't matter where I go, but there's a pair right there that line up vertically, and that's all it takes is one pair. So I don't even have to worry about any more of them. This is not a function, so this would be no, and I would say x equals -2 is paired with two y values. All right, and you could actually give those y values, or you could just say it's paired with two y values. It doesn't really matter there. All right, so let's take a look at the next one. All right, so a function test. If a vertical line touches the graph at more than one point, then you have one x with two y's. So the graph is not a function. And that's what I was talking about on the other side. When I lined up those 2 points vertically, just like this, those 2 points failed a vertical line test. So they would both share the same x. All right, that's the easiest way to tell if something's a function or not. Domain and range. When we talk about domain and range, domain is this domain is the set of real numbers. So basically anything that you could think of that's a real number, decimals, fractions, square roots, cube roots, whatever, the set of real numbers, those are your inputs, that's your domain, that produces real values for your output. Basically what you're saying here is the domain is your set of inputs and the range is your set of outputs. Okay? So your domain is usually what we would consider the x coordinates, and the range is your y coordinates. So the domain is the set of x coordinates of all points on the graph. Now, if you look at this graph, if I were to start looking at the x values, I don't care about the y's, all I care about is the x's. I've got an x of starting at 2, and my last x starts or finishes at 8, but all of these other values in between also have x values. So I would say that the domain of this function goes all the way from positive 2 up until positive 8. And there's a couple of ways you can write that. You can say x is greater than or equal to 2, and at the same time it's less than or equal to 8. Or we can do interval notation where we do a bracket with a 2, 8 and another bracket. And basically what the bracket tells you is that the 2 and the 8 are part of the domain. If they weren't part of the domain, if there were open circles, we would use parentheses there, and we'll see that later on. When I talk about the range again, all right? So we go to the range. This time we're looking at the up and down, the y values. So my y values start at positive 1, and they go up, 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 just like this, and they stop at positive 7. So my range would be 1, y is greater than or equal to 1, but at the same time it's less than or equal to 7, or we could say 1, 7 using the brackets again. All right? So let's take look at a few examples, okay? So it says tell whether each relation is a function and give the domain and range, okay? So the first thing I notice on letter A, is it a function? Oh, no, it's not. No, no, no. Fails vertical line test. Fails vertical line test. All right? So easiest two places to see that, 0, 4 and 0, -4. Two x's that have different y values. So that tells me right away it's not a function. Just because it's not a function, though, doesn't mean it doesn't have a domain and range. Domain is your x values. What's the smallest x value on my graph? It's over here at -4. What's the biggest x value on my graph? Oh, excuse me, that's -6. The biggest x value is +6. And everything in between is connected, all the way from -6 to +6. So we would say this as x is greater than or equal to -6, but less than or equal to +6, or I like intervals, -6, 6, done. The range, on the other hand, again, those are your y values. Those are your up and down. So what's the smallest y value? It's down here at -4. The biggest y value is up here at +4, and everything in between touches a y value from -4 to +4. So -4, +4, we're talking about y values that are greater than or equal to negative, less than or equal to positive, or we could say -4, 4. Done. Okay? All right. Next one, I would encourage you to turn off the video and try some of these on your own as you go through this. Okay? Letter B, function or not a function. So the first thing I'm going to do is I'm going to go through and look for repeating x values, and I see one here and here. This is a no. All right? That is definitely not a function. What's the domain of that function? It's all of the x values. Now, this is not a connected graph. This is 5 points. So if you were to graph these, literally you would end up with something like this. You'd have 1, 2, we're just going to put that there. We'd have 3, -5, so maybe down here. 0, comma 4 would be up here. Negative 1, 6 might be here. And then 1, comma 9 would be way up here. And you can see that I've got these 2 points that are vertically lined up. But that's it. So when I go to talk about the domain, there's no connection in these points. So all I'm going to do is I'm going to list all the x's. 1, 3, 0, negative 1, and I don't need to list positive 1 again. And then usually we use these little squiggly brackets. So we say it's the set of numbers 1, 3, 0, negative 1. Same thing for the range. Just what are the y values here? Well, usually we can put usually these would be put in order too. It really doesn't matter here, but I'm just going to go in order here. So negative 5 is the smallest one that I see, and then 2 and 4 and 6 and 9. So my range is the set of, that's what these little squiggly brackets mean, the set of these 5 numbers, and that's it. Okay, we wouldn't say that the range is negative 5 to 9. We would not do that. No, 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 because it doesn't include everything from negative 5 to 9. All right, so letter C, is it a function? So the first thing I do is I do that vertical line test, because I've got a graph where I can actually do that. Yes, this is a function. This thing passes the vertical line test. Passes vertical line test. Okay, so what's the domain? Now, hopefully this graph looks somewhat familiar, but it's a function called a rational function. It's y equals 1 over x. Okay, and so if you were to graph y equals 1 over x, we end up with a graph that looks like this. I don't care about the equation right now. I just care about what are all the x values. So the arrow here on the left side says that this thing keeps going all the way to negative infinity, and the arrow on the right side says it keeps traveling to the right all the way to positive infinity. So if I were to look at the domain here, the graph goes from negative infinity over here all the way across, and even though it rolls down, my x's are getting bigger and bigger and bigger, and then all of a sudden it skips over the number 0. And it picks up on the other side, and it goes from 0 all the way to positive infinity. So there's a couple of different ways, again, that you could write this. You could say that x is in the set of reals. However, x does not equal 0. That's what that vertical asymptote is. Or you could say negative infinity, comma 0. Notice I'm using parentheses now because we don't ever actually touch negative infinity, and we're definitely not touching 0. And then also we go from 0 to positive infinity. So that notation there is basically saying, look, it's negative infinity to positive infinity without 0 being included. And the range, the same thing happens on the range. If you look at this graph, it goes down forever, and it goes up forever. And the only thing I skip over is this horizontal line at y equals 0. So we could say that y is in the set of reals where y does not equal 0. Or we could say, again, just like below, negative infinity, comma 0, and 0, comma infinity. Okay? All right.